Well, this is John Black, Super Chemist, here to show you how to make formic acid. But this should be easy, okay? Because you don't have to worry about over-oxidation. Now, if you want to see the actual experiment, flip through to the middle of the video because I'm going to go over the stoichiometry. Here's the equation. It's the same equation as the last one for the aldehydes. The only difference is a double dis and a double dis. This is your chromic acid. So obviously, if I used half of this, I'd only get it to oxidize to, I'd only have enough to oxidize it to an aldehyde. I need twice as much because I need to oxidize that aldehyde to a carboxylic acid. So that's the only difference. Here's my molar weights, timed about how many moles they want me to use. And then I chose 0.05, that's 5%. So I took 5% of everything. So I need 4.8 grams of methanol, 29.4 grams of dichromate, 23.2 milliliters of sulfuric acid. Now, last time I didn't boil my sulfuric acid. It looked pink, you could tell. This time I boiled it to get rid of all the stuff that's in there. I mean, it's not perfect, but it's a lot better. I'm not going to account for the water. I actually distilled some of the water out too. So I'm just going to, because I ain't worried about having too much sulfuric acid. If I have a little extra, it's no big deal. Dichromate, I'm going to put in a little bit more, like 31 grams, 31.4 or something like that, so that I know that I have enough in there to oxidize everything. Okay. Last time I used 71 milliliters of water. Like I said, I don't care if it's dilute as much as I did last time, because I want it all to be oxidized twice. So I'm just going to put the same amount in, 75 milliliters though this time. My yield should be 6.95 grams, and to get the milliliters I divided by the density. Grams cancel out and I get milliliters. 5.7 milliliters is my yield, or what I should get. So keep in mind, this is an easy experiment here. I can't screw it up. Formic acid does form an azeotrope with the water, and we'll get to that when we get to the experiment. First thing, let's make some chromic acid, and that way we can drip it into our methanol. Here's my chemicals for my chromic acid. I got 31.2 grams of dichromate. You can see that yellow stuff on there is chromate. I had about 72 grams of water. I measured about 30 milliliters of sulfuric acid right here. The reason why it looks dark like that is I had this chromate inside there, and some of the dust was still in there, and that's why it looks kind of orangish brown. Now I'll mix these together and make my chromic acid. Alright, now here's my setup. I got my chromic acid in here. Most of it. I had to add another 100 milliliters of water because I couldn't get it to dissolve. So anyways, I did. It's almost dissolved. It's good enough because I want to add heat. As you can see, I got a condenser, a good kind with a coil in it. I'm going to add my methanol up here on the top, and then it'll slowly go down there and turn that green, because it'll go from a +6 to a +3 oxidation. Alright, now I got exactly 4.8 grams, and that's 6.06 milliliters. I have pretty much exactly on everything here. I've never been more precise. There it goes. I'm going to toss some in right now. Just a little. And let me turn my pump on. This will produce formaldehyde, and I don't want it escaping. Oh, there we go. And you noticed last time I put the I put it in the other way. I put the chromic acid into the stuff I was making. I wanted to oxidize. This stuff here, I don't care if it over-oxidizes, so I don't care if it's surrounded by oxidizer. Before, when I was trying to make an aldehyde, I didn't want, I throw in the alcohol. I don't want it surrounded all by oxidizer, so it definitely get oxidized twice. I'd rather do it the other way around. It's getting darker. I definitely see some gases coming out. Now I wish I was making formaldehyde. There's a lot of gas coming out. I don't smell anything up on top yet, so it's good. It's definitely turned green already. The red orange is gone. Put the cap on the lid. I know you shouldn't have a closed system, but I put it on real loose. So I don't want this stuff getting out. It's definitely turning it green. At least I got rid of some of the clouds stirring it up. Wish I had my stir bars. Yeah, it sure gets rid of the cloud that was in there. Barely smell it at the top of the condenser. All the gas is gone now. I'm going to put some more in. Well, it sure takes a long time to get through that condenser, even as a liquid coming down. Here it comes. Now when that goes in there, I bet some more gas will come out, that's for sure. Maybe I had it too hot when I was doing the acetylene, when I was trying to make the acetaldehyde, I mean. Maybe I had it too hot. I should have just put it in there a little above room temperature. Although I'm not seeing any gas this time. Still barely can smell anything up on top. Alright, I'm going to put some more in. Ooh, that time I put a lot. There it goes. I'll cover the top up again, cap it. I didn't tighten it, it's just sitting on there. Keep those gases in there. Formaldehyde wants to be a gas. You can't see it on camera, but there is a little slight, I could see a slight gas inside there. Yeah, I gotta stir it manually because I got no stir bars. And I'm gonna add some more. I'm amazed I don't smell that much formaldehyde. Okay, now it looks like it's boiling inside there. Oh, it's getting hot. It's getting real hot. Starting to boil. Alright, well, I was going to put the heat on. I guess I can just reflux it with its own heat. So I'm going to reflux this for about an hour, maybe a half hour, and I'll get back to you. Well, as you can see, it stopped being hot, so I had to, well, it didn't stop being hot, but it stopped heating up past 77, so I had to put my heater on. I got that tin foil up so it keeps all the heat in around the flask, but you can see it's starting to reflux. Here comes the drop right now. So I'll let this go another 20 minutes. You can see I got paper towels up here. I'm getting a leak there because the barb port that comes out that I put my hose on is smaller on this condenser. I tried putting tape around it. It didn't help. So of course then I use napkins. Now you can see it bubbling. It's boiling. I had to let it reflux for about a half hour. I put a little bit of water down the condenser so it'd wash any methanol that didn't make it all the way through. And then I added about a milliliter of methanol to this pot after it cooled down, because I did add extra dichromate and I wanted to neutralize that. So this way, you know, I can neutralize that. And now I'm going to set up for distillation. Get out my formic acid, azeotrope. Alright, I'm going to go downstairs and do this, but I'm going to show you the gist. I got my hot plate. Although downstairs I got gas, so it'll be cheap, it'll be almost free. I can distill that up. It's going to go up this Vigorx column. And I got a condenser here, my thermometer. Come back down. I'll collect it in here. And obviously there's my pump for my water condenser. Well, 7 grams was my theoretical yield, the most I could get. This azeotrope is 77.5% by weight of formic, formic acid being the majority. Let's say we got 75%. I did use a Vigorx column, so I'm sure I got close. That means that 75% is formic acid and 25% is water. So I would take the 7 grams, divide it by 3 times 4 for my 3/4, and I would get 9.3. That means I need 9.3 grams of liquid that I distill so that I get the 7 grams of methanoic acid. You know what I mean? And then the rest would be water. Now I took it divided by the density of pure formic acid, which is 1.22, but I'm sure it's closer to 1, which would make this a little bit higher. So I distilled 8 milliliters of liquid out, and that should be probably about a 75% azeotrope. If you wanted to dry it out, you could use magnesium sulfate, maybe even molecular sieves. I don't know if you can use molecular sieves on weak acids or not. I know you can't use them on strong acids. There it is. You can see it's pretty clear, and doesn't smell like I thought it would. It's not that bad, really. But then I don't have that much. So now, if you want to know what the yield is exactly, watch my next video, and I'll be doing something with it to see how much is actually really there. Anyways, always remember, science is great.